morning everyone. So today we discuss about the reversible reactions. Okay, this is the one of the types of reactions. Okay, so reversible reactions means generally in a reaction the reactants give the products, okay, which involve in the reaction they known as reactants. Means the starting material we are taking for the reaction. The starting material we are taking for the reaction are called reactants. The formed new compounds are treated as products. Okay, let's see one example. If you know, on heating calcium carbonate, on heating this calcium carbonate, we know that there is a formation of calcium oxide and carbon dioxide. Okay, so this is a reactant, this is product. For example, N2 plus 3H2 gives 2NH3. Here what are reactants? These are treated as reactants. These are treated as products. Means the starting materials are taken for the reaction are called reactants. The formed new compounds are called products. Okay, so reactants forming products. So this reaction is treated as forward reaction. N2H2 combined the same form as ammonia forming. So this is a forward reaction. So on heating calcium carbonate we got lime and carbon dioxide gas. So this is forward reactions. Okay. If the reverse reaction takes place, so see here again. If there is also possibility based on the conditions, NH3 is also forms nitrogen and hydrogen. Means here the products formed the reactant exactly reversely. Okay, so first time formed manaki forward reaction lo and starting material N2H2 తీసుకున్నప్పుడు both undergoes reaction and forming NH3. It's okay, it's called forward reaction. So now after some time, after some amount of NH3 is formed, like కొంచెం NH3 form అయిన తర్వాత ఏమంటే NH3 also decomposed to N2 and H2. And that is called backward reaction. Okay, so already we know these are reactants. So these are products. So react into products. It's a normal reaction. It's called forward reaction. Okay. For example, the product forms the reactant. So a product reverse malli reactants to form chesanuko, they called as backward reaction. The products are forming reactant is called backward reaction. Okay, so if this takes place for all reactions, no, it is observed only in few reactions. Okay, in many reactions only forward reaction takes place, backward reaction does not takes place. Means it totally depends on nature of the reaction. It totally depends on the nature of the reactant and products. Okay, మనం తీసుకున్న స్టార్టింగ్ మెటీరియల్ ఫామ్ అయిన కాంపౌండ్స్ బేస్ చేసుకొని అది బ్యాక్వర్డ్ అవుద్దా లేదా, it decides on that only. Okay, if backward reaction is also possible, then that type of reactions are treated as reversible reactions. Simple. Reverse means exactly back. So backward reaction is possible, then that is treated as a reversible reactions. So reverse they treated as irreversible reactions. Okay, now we see some examples of a reversible reaction. Here see on heating, just now we said that calcium carbonate, limestone atom, calcium carbonate. So on heating calcium carbonate, we know that CaO plus CO2 is formed. So forward reaction takes place. So this is the experimental. So all reactions మనం check చేయలేం. These are all experimental given reactions. either reverse అవుతుంది, either reverse అవ్వదు. It is totally given in book for us. Okay, directly we can't decide the whether it is a reversible reaction or irreversible reaction. Okay, మనం డైరెక్ట్గా ఇప్పుడు అన్నోన్ రియాక్షన్ ఇస్తే అది రివర్సిబుల్ అవుతుందా రివర్సిబుల్ కాదా మనం ఫైండ్ అవుట్ చేయడం కష్టం. there is a fixed examples are there, we need to remember that examples. Okay, for example, on the heating of limestone, reactant on heating these two compounds are formed. So we know the physical state of calcium carbonate, solid. This is solid, this is gas. Okay, in forward reaction what happened? CaCO3 formed CaO and CO2. In reverse reaction what happens? These two reactions takes place forming CaCO3. So ఈ two combined అవుతే మనకి CaCO3 form అవుతుంది. Okay, but here the CO2 present in the form of gas, కాబట్టి సో ఫామ్ అవ్వగానే మనం వెజల్లో చేస్తున్నాం, ఒక వెజల్లో చేస్తే సో ఫామ్ అవ్వగానే ఇట్ ఈజ్ గ్యాస్ కాబట్టి అట్మాస్ఫియర్లోకి మిక్స్ అయిపోతుంది. ఇట్ వెంట్ into the atmosphere. ఓన్లీ సిఏఓతో బ్యాక్వర్డ్ రియాక్షన్ పాసిబుల్ అవ్వదు. CO2 కంబైండ్ అవుతుంటే నీకు రివర్స్ రియాక్షన్ పాసిబుల్ అవుతుంది. బట్ ఇక్కడ CO2 గ్యాస్ స్టేట్ కాబట్టి వెళ్ళిపోయే ఛాన్స్ ఉంది. దట్స్ వై రివర్సిబుల్ రియాక్షన్స్ చేయాలంటే సో కాబట్టి మనం ఈ టోటల్ ఈ మిక్చర్ ఏం చేయాలి, మనం వీ నీడ్ టు టేక్ ఏ క్లోజ్డ్ వెజల్. Reversible reactions, the main condition is they must take place only in closed vessels. Okay, unli solid state lo unte it's no problem, but maybe in many reactions there is a formation of some gaseous products. Okay, మన ఫామ్ అయిన ప్రోడక్ట్స్లో ఒక్కటి గ్యాస్ ఉన్నా కూడా అది టోటల్ గ్యాస్లో అట్మాస్ఫియర్లో మిక్స్ అయిపోతే సో మళ్ళీ రివర్స్లో రియాక్షన్ అవ్వడానికి ఏమి ఉండదు అక్కడ. కాబట్టి అప్పుడు రివర్స్ రియాక్షన్ చాయిస్ ఉన్నా కూడా రివర్స్ రియాక్షన్ అవ్వదు. దట్స్ వై ద కండిషన్ ఈజ్ రివర్సిబుల్ రియాక్షన్ జనరల్లీ టేక్స్ ప్లేస్ ఇన్ క్లోజ్డ్ వెజల్స్. ఓకే, means we can define the reversible reactions as the reactions in which both forward and backward so the reactions in which both forward and backward reaction take place are called reversible reactions. Okay, so forward reaction means reactant to product. Okay, reactants to product. next products to reaction reactant, sorry. Okay, reactant to products is called a forward reaction. Okay, so these are total basic you have to understand perfectly. This is called forward reaction. ఇలా product to reactants होते that is called backward reaction. Okay, so if in a reaction both takes place simultaneously, okay, simultaneously both forward and backward reactions are possible, they treated as the reversible reactions. Okay, now we see what is the other point? Generally reversible reaction takes place in closed vessels. Okay, okay, write down. The main condition is the important point is reversible reactions takes place in which type of vessels? Closed vessels. Open vessel లో కొన్ని gases ఉంటాయి. సో అవి gases వెళ్ళిపోతే మళ్ళీ రివర్స్ పాసిబుల్ అయ్యే ఛాన్స్ ఉండదు. దట్స్ వై దే టేకెన్ ఇన్ రివర్సిబుల్ రియాక్షన్స్. సో దే టేకెన్ ఇన్ క్లోజ్డ్ vessels. Okay, reversible reactions are taken in closed vessels. So there is a condition. Okay, and the next we see some examples for reversible reaction. So all reactions are not reversible reactions. Okay, so some reactions are not reversible reactions. Okay, what is there is also a separate name for them. Okay, reversible chance claim reactions ki there is separate what is that's called irreversible reactions. Okay, that's irreversible reactions. Okay, we see some irreversible reactions first. Okay, so for example, potassium chlorate. Potassium chlorate on heating, we will get potassium chloride and oxygen only. Here backward reaction does not take place, only forward reaction takes place. Okay, so such type of many I am just giving an example for it. The main our topic is reversible reactions. Now we see examples of reversible reactions. Okay, these are the fixed example given in experiments condition. So N2 plus H2 gives NH3. So forward reaction, backward reaction both take place. Kabatti we giving a small this half arrow mark. Okay, but it takes place at some conditions. We know that it has a catalyst and a promoter. It also requires some pressure also. Okay, 400 atm atmosphere pressure and 450 degrees Celsius temperature. This is the very important reversible reaction. And some more examples are there. So here all are present in gaseous state. Gas, gas, gas. So on CaCO3 also, it is also a reversible reaction. Okay. CaO plus CO. Already it is balanced. So what are the physical conditions? Solid. It is in powder form. Calcium carbonate. It is in solid. It is in gaseous state. Okay. Now next. Here's one more example. Iron when react with water, hot water, nothing but steam. Okay. It is also a reversible reaction. So how to know whether it is a reversible reaction or not means there is no technique to know the reversible and irreversible reaction. To know any unknown reaction, they must be. This is a gaseous state. It is also steam. Okay, steam state to know this gaseous state. So iron in this form of solid. It's a solid. So it is also formed. So very hot. Echo heat channel. So then a red hot condition enter. Red hot means so iron total ga red ga vachetaట్టుగా heat చేయాలి. So it is also best example for reversible reaction. So మనకి given example by have చేయాల్సిందే కానీ మనం own గా ఒక రియాక్షన్ ఇస్తే అది రివర్సిబుల్ కాదా ఫైండ్ అవుట్ చేయడం ఇట్ ఇస్ నాట్ పాసిబుల్ ఫర్ us. Okay. But it is compulsory to know, to remember at least a few examples. So I give some more examples. Here see some more examples. Hydrogen iodine, forming hydrogen iodide. Here also, so it is a gas, it is a solid. See one more example. Here also all gases. Okay. So these are the generally important reversible reactions. Here important thing is actually this symbol, we use this symbol for reversible reaction. Actually there is a important thing is there according to so for this two sides symbol, so that is also known as equilibrium symbol. An important thing is we know what are reversible reactions. The forward reaction and backward reaction simultaneously takes place. Simultaneously forward reaction takes place in reversible reactions. Okay, at a particular condition. So మనం reaction start చేస్తాం. So start చేసిన తర్వాత react forward అవుతుంది. So products కొద్దిగా ఫామ్ అయిన తర్వాత బ్యాక్వర్డ్ రియాక్షన్ స్టార్ట్ అవుతుంది. సో ఆఫ్టర్ సమ్ టైమ్ అంటే సైమల్టేనియస్గా ఫార్వర్డ్ అవుతుంది, బ్యాక్వర్డ్ అవుతుంది. So after some time what happens ante the total reaction mixture composition becomes constant. Reaction mixture become constant ante there is no change in the concentration, and the concentration means we can say composition. Okay, nothing but simply we can say amount. The amount of reactants, amount of product same అనిపిస్తే మనకి. So it just appears like the reaction was stopped. ఓకే, ఒక పర్టికులర్ టైం తర్వాత ఒక్కొక్క రియాక్షన్కి ఒక్కొక్క టైం ఉంటుంది. సో ఆ పర్టికులర్ టైం తర్వాత ఏమవుతుందంటే టోటల్ రియాక్షన్ మిక్చర్ కాన్స్టెంట్ అవుతుంది. రియాక్షన్ స్టాప్ అయిపోయినట్టు అనిపిస్తుంది, బట్ ఇట్ ఈస్ నాట్ స్టాప్డ్. బట్ వై ఇట్ ఈస్ లుకింగ్ ద అపియర్స్ లైక్ ఇట్ ఈస్ స్టాప్డ్ మీన్స్ the rate of forward, rate and ikkada speed, you know that the speed of forward reaction becomes equal to the speed of backward reaction. The forward backward reaction same speed తో అవుతున్నాయి. So that condition is called equilibrium. Okay, so generally equilibrium మనం ఈ సింబల్ యూజ్ చేస్తాం. When rate of forward and the rate of backward reactions are equal, it is known as equilibrium. It is known as equilibrium state. Generally మనం ఈ సింబల్ యూజ్ చేసేది ఈక్విలిబ్రియం కి. Reversible reactions lone it is possible. Okay, so this was about reversible reactions. Okay, so now we see the next type of reactions. So are you writing the notes perfectly? Are you following the videos? Okay, it is compulsory because it is totally basic chemistry. You have to follow the every class regularly and write the notes properly. Okay, after coming to the school we check the notes. And the next thing is you have to listen the previous videos also. For example, so today you are listening this video. So after this you also listen the yesterday's video, not all earlier videos. Just every day you need to listen 2 videos, today's video and yesterday video. Okay, so that's important one. For revision it becomes very easy for you. So next we see the next type of reaction, that is thermal dissociation reactions. Just wait. Thermal dissociation reactions. Let's see, thermal dissociation. Thermal means generally the word thermal indicates about the heating. Okay, so heat చేసినప్పుడు dissociate reactions ఏమంటామంటే they treated as thermal dissociation reactions, just like decomposition reactions. Okay, just on applying heat they dissociate, just like the decomposition reactions only. Okay, this type of reactions are called dissociation reactions. Okay, So here, so what is the difference between the normal decomposition? Normal decomposition reactions also same. Then what is the difference between the normal decomposition reactions and thermal dissociation reactions? For example, normal decomposition reactions. Normal decomposition reactions and only one product. Sorry, only one reactant. Okay, reactant only one untadi. Products more than one untadi. Okay, more than one. On heating potassium chlorate, we will get KCl and oxygen. Potassium chloride and oxygen. So it is treated as a decomposition reaction. For example, if you take phosphorus pentachloride, okay, on heating it forms phosphorus trichloride and chlorine. Okay, so it is also decomposition reaction. So, but it is example for thermal dissociation reaction. So, they heat chestam, they heat chestam. Both are similar. But what is the thing is, this is not a reversible reaction. There is no reverse a choice money. It is irreversible reaction. So, ikkada thermal dissociation the word use chestam if it is reversible. So, PCl5 phosphorus pentachloride heat chestam. Heat cheste we will get PCl3. What is the name of PCl3? Phosphorus trichloride and Cl2. So mali దీన్ని కూల్ చేస్తాం అనుకోండి. On cooling what happens? ఈ రెండు మళ్ళీ కంబైన్డ్ అయిపోతాయి. They combine together and forming PCl5. అంటే సో నార్మల్ డీకంపోజిషన్ రియాక్షన్స్ మోడలే అవుతాయి, బట్ దే ఆర్ రివర్సిబుల్ అవ్వకుండా ఓన్లీ ఫార్వర్డ్ అవుతాయేమో. సింపుల్ వీ కెన్ సే కెమికల్ డీకంపోజిషన్ రియాక్షన్స్. అదే సేమ్ డీకంపోజిషన్ రియాక్షన్స్ మోడలే, బట్ దెర్ ఇస్ అ పాసిబిలిటీ ఆఫ్ రివర్సిబుల్. ఒక బ్యాక్వర్డ్ రియాక్షన్ కూడా పాసిబుల్ అవుతాయి కూల్ చేస్తే. దట్ ఇట్ ట్రీట్ యాజ్ ఏ థర్మల్ డిసోసియేషన్ రియాక్షన్స్. మీన్స్ దే ఆర్ జస్ట్ లైక్ డిసోసియేషన్, జస్ట్ లైక్ డీకంపోజిషన్ రియాక్షన్స్, but these are reversible, they are not reversible. Okay, so means we can define that the reversible reactions or the reversible decomposition reactions. The reversible decomposition reactions are called thermal dissociation reactions. Okay, so in this process so what happens on cooling? So mali thermal dissociation ante man heat chesta hote. So on cooling mali em hotayi, again products form hote. Okay, to form reactants. Okay, on cooling it takes place. So take some examples. Phosphorus pentachloride, phosphorus trichloride and just chlorine. All are here. PCl5 is the solid, gas. So the forward reaction takes place on heating. Okay, it's a forward అవ్వాలంటే మనం కంపల్సరీ హీట్ చేయాలి. సో బ్యాక్వర్డ్ అవ్వాలంటే we need to cool it. Okay, let's see one more example. So there is a very specific examples are there. There is ammonium chloride, dissociation of ammonium chloride. So left side the reactants flow only one compound ఉంటుంది మనకి. Okay. So on heating it forms ammonia and hydrogen chloride. I think already it is balanced. Okay, so then it is the solid form, gas. On cooling what happens? Again reverse takes place. On cooling reverse takes place. Okay. Here one more important thing is so decomposition and thermal dissociation are looking similar reactions, but the only decomposition reaction they are not reversible, only forward reaction takes place. But in this type of reactions reversible also takes place, just only on cooling, only cooling only it is possible outside. Okay, next we also said the all reversible reaction takes place only in the క్లోజర్ వెజల్. జనరల్గా క్లోజర్ వెజల్ ఎందుకు యూజ్ చేసినా మనం మెయిన్లీ అక్కడ గ్యాస్ స్టేట్స్ ఉంటాయి. ఓకే, గ్యాస్ కాంపౌండ్స్ ఉంటే అది అట్మాస్ఫియర్లోకి మిక్స్ అయిపోతే మరి రివర్స్ అవ్వడానికి ఛాయిస్ లేదు. కాబట్టి we said that reversible reaction takes place in closed vessels. బట్ అన్ని సాలిడ్స్ లిక్విడ్స్ ఇట్లా మరి ఎలాగే ఉంటాయి, we can take it ఓపెన్ వెజల్లో తీసుకోవచ్చు. ఓకే, సో నెక్స్ట్ there is some other type of reaction. The main important reactions are there. That is oxidation and reduction reactions. Okay, in the next class we see it. Okay.